So welcome everybody. So how many people is this your first time to Etelman? Oh, quite a few of you. Oh, well, welcome. My name is Dave Smith. I'm actually a retired physicist at VI, but I still hang out with folks around here. So I'm going to kind of talk you through this telescope. This is our main telescope. It's not set up for you to look through it, but the telescope's outside. You can see all you need to see out of those. Those are good telescopes out there as well. This one is set up with a color wheel and a camera with a CCD. So we actually look at the pictures that it takes on the computers downstairs. So you're walking out, you probably saw that computer room in there with all the monitors. What it's doing right now, you notice every once in a while it moves, is it thinks it's doing a calibration, but it's not because we didn't open up the dome. And the reason is because there's so much wind out there, it's really turbulent, so we wouldn't get very good pictures tonight anyway, regardless of the rain. But if it were a good night, what it would be doing is it moves around every couple of minutes to a new point in the sky, a place where it knows that there are stars that we know about, we know their locations, and these little encoders on the motors here make this thing turn this way and this back and forth in this direction, tell it exactly what its position is, and later in the night we run a computer program that goes and picks those stars, looks at those readings, go to the next star, look at those readings, and it can create a really accurate map so that we know exactly where this thing points. And we want to be able to do that because we always want to be able to point it exactly where we want. Particularly for this telescope, we're part of a consortium that looks for gamma ray bursters. How many people know what a gamma ray burster is? What's a gamma ray burster?
I've heard of it.
Yeah.
I'm pretty sure it has to do something with, I think I was watching a documentary when I discovered something. Found something like that. It's like two black holes collide and they can develop.
Well, it could be. The truth is we don't really know what they are. They're probably something a lot bigger than that. Gamma ray bursters, all the ones we've seen, are billions of light years away. It means the light's taken billions of years to get to us. And so that means they happened billions of years ago. And that's pretty good. Because if they were still happening and one happened anywhere near us, we'd be toast. A gamma ray burster puts out more energy than an entire galaxy. And it does it for maybe a day, maybe a few weeks. We have short gamma ray bursters and long gamma ray bursters. And we don't really know what they are. They're something that occurred earlier in the universe. They're incredibly energetic, catastrophic events. And the only way we can learn about them is for light. And so that's what we use this telescope for. We're a part of the consortium. When a gamma ray burster is detected, you might only have 24 hours to take data. And so as the Earth rotates, we have a set of telescopes, and we're the only telescope for 4 hours east and 4 hours west that can take this kind of data. And so they happen a few times a year.
Okay.
And so when they happen, we need to be ready.
Yeah.
We did one this summer, and also another one about a year ago, it's our most famous one. That was one that also was coincident with gravitational wave detection. So it's the first one we've had where a gamma ray burster and a gravitational wave detection was the same event. So we know that they do both of those things. So what happens is that that light comes up and makes this curve and does this and maybe gone in a day. So how do you find out that they're happening? Well, if you're really lucky and you happen to be looking up there somewhere, you might see it suddenly, oh, there's a star where there wasn't a star before, but that's not very likely. Instead, what we know is that they give us a X-ray signal. So we have satellites up right on the Earth, and anytime they get an X-ray signal, they locate it, and they send a message down to all of us here on Earth and say, point your telescopes there, where it happens to be. And so all of the people at the telescope get that signal. And this is a robotic telescope, so you can go and come in on it with the computer, or it's actually set up to take those signals directly. Because it's 3 in the morning and we're asleep, the computer will say, oh, okay, open up the dome, swing this guy over, and start taking data. And so we'll take data for anywhere from a few hours to 8 hours. They're likely to catch it from one horizon over to the next one. And then as the sun comes up here, somebody where it's still dark starts their telescopes and they take the data. So hopefully we'll have continuous data. So when you see these curves, they were taken by telescopes all across the face of the Earth because you want to look at it at night. It does that. So what this guy does is simply take as much data as you can. Of course, if the weather's not good, you're out of luck. But if the weather's good, you can take as much data on this thing as you possibly can. Now you notice that the fork turns like this. You draw a line straight through this telescope. That's the axis of the Earth's rotation. So while it's taking the data, right now it's moving a lot. This thing's moving right now, you just can't tell it, but it's following the Earth very, very slowly. So as things move in the sky due to the Earth's rotation, it follows very carefully.